Hello everyone, how are you? Hope you all doing well. My name is Panda, and today we have a new video in the Machine Learning Design Patterns playlist. After all these long introductions and many reviews, we will start today with the first pattern in the book, which is the hashed feature. But before we begin, let's quickly go over the process we will be following. The first thing we'll start with is defining the problem, and then we'll provide an example. Then we'll start discussing possible solutions, which may come to mind, but they might mess up other things, or not be the best approach. After that, we'll mention the solution from the pattern itself, and how it solves the problem. Then we will finish with the trade-offs and the advantages of this design pattern, as well as any drawbacks. That's enough for an introduction. Let's move on into the problem that the pattern will solve today. The pattern we are discussing today will help us solve three problems when dealing with categorical features, which are incomplete vocabulary, cardinality, and cold start. You might be thinking, whoa Panda, what is this? I don't understand any of it. Don't worry, we'll go through each of these one by one and explain the problem. When we perform one-hot encoding for categorical features, we need to know the list of categories present, or at least the entire vocabulary that could appear for this feature. For example, if the feature is about nationality, it's easy because we can obtain all the possible nationalities, and can perform one-hot encoding based on that. But we face a problem when the feature is, for example, an ID for a hospital, or an ID for a doctor. But you might ask, well, where is the problem with that? Let me explain simply. You need to make sure that all the IDs are available in the training data when you are doing the encoding. You might ask, okay, but where is the problem in that? Well, when you're splitting the data, you're splitting it randomly. And this randomness could result in some categories being rare or not present at all in the training data. So when you try to do encoding, a category might not appear. What happens is that when the model encounters this unseen category, it will error out and fail to make a prediction. And if it's deployed, for example, the application will exit due to the error. So the problem here is clearer now. The second problem is cardinality, or the issue of features with large number of categories. For example, if we have a categorical feature like nationality, and there are over 200 different possible categories, this might not pose much a problem. But in the case of IDs, you might have thousands of hospitals or millions of doctors. So if you attempted to do one-hot encoding for all of them, you will end up with millions of features. This is a huge problem when you're training a model on all of these features. As you know from the curse of dimensionality, the more features you have, the exponentially more data you need for the model to learn the relationships between those features. The more features you have, the more data you need for the model to effectively learn without overfitting. And of course, the data may not be easily available. So that's another challenge we need to figure out how to handle. So that's all for cardinality. The last problem we have is the cold start problem. You might say, Panda, I will solve the vocabulary problem by making sure I split the data according to the distribution of this feature. And by that, I can guarantee that the training data contains all the categories. And at that point, I can confidently do one-hot encoding. I will tell you, you're solving it during training, or at that specific moment. The cold start problem is about encountering a new category that wasn't present in the data before. This means even if you handle it during the training, you will never be able to validate or ensure the new category during inference. For example, it could be a new hospital ID or a new doctor ID. Of course, you might say, okay, I will just handle it like you mentioned in the last video, by using the missing feature and dummy encoding, and the system will just treat unknown categories as missing and proceed with that. I will tell you, that's technically fine. But you have only handled the first and the third problem. But you forgot about the second problem, which cannot be ignored. Anyways, as we go through the book, there are many solutions to the problems we'll be discussing. But let's focus on the pattern we are talking about today, and see how it handles this problem, and why it might be better than other solutions. So keep this in mind. If you feel there is another way to solve the problem, and I haven't mentioned it, that doesn't mean it's not valid or that it's wrong. It's just that we are here to see how this pattern solves the problem and its pros and cons. Actually, drop the solution in the comments so we can explore it together. Now let's go back and take an example from start to finish. for these three problems and see how can we solve them. Let's assume we want to create a model that predicts how delayed a flight will be. We have 374 airports, and there's a feature that tells us where the flight is coming from. It also tells us that there are some airports that appear 2 or 3 times only in the data. So there is a chance that when we split the data into train and test, the vocabulary may not be complete. Also, 347 is a large number. So if we create a feature for each airport, we will have a lot of zeros in the example, and the data will be sparse. This is the cardinality problem. And of course, it's common to have new airports appear later and show up during inference. This is the cold start problem. Now let's look at the design pattern we're talking about today, called the hashed feature, and see how it solves this problem. So what does hashing mean? It's a mathematical operation that takes input and transforms it into an output using a mathematical process, which could be a string or a number. Given the same input, you will get the same output. That's why we'll use it during both training and inference. So what are we going to do? We will convert all our airports into a 3-letter strings, or their abbreviations. For example, it could be the IATA code, but in general, it is just the abbreviation of each airport, which typically consists of 3 characters. Then we will select a bucket size, like 3, 5, or 10, depending on what we want. Each airport will be assigned to one of these buckets. After that, we will take the 3-letter code for each airport, apply the hashing function, and pass it along with the bucket size. What happens is that the 3 characters will go through the mathematical operation, and then we take the resulting number, we apply the modulus operation based on the bucket size we chose. The number that comes out of all of this is the bucket in which we will place this airport. And usually, we take the absolute value of this modulus result. Let's take a look at an example to make this clearer. As you can see, we have a column for 3 airports and 3 other columns, each with a different bucket size, 3, 10 and also 1000. The picture is kinda cropped from the top, my bad. If we chose a bucket of size 3, we will distribute all of the airports into one of those 3 buckets. The same process applies if the bucket size is 10 or even 1000. A quick note, there are many different hashing functions, and the one we're using today is called the form fingerprint. But I don't want you to worry about the specific hashing functions available, or the exact operations that the form fingerprint performs. What you need to know is that it takes a string in our case and returns a number based on the size we chose. For the airport, it's like grouping or clustering the airports together. Before we look at how this is useful or its potential drawbacks, let's check if it actually solves the 3 problems we mentioned earlier. The first problem we had was out of vocabulary. And if you recall, even if an airport is missing or occurs less often in the training data, when you tell me during inference that a new airport is coming up, the hash function will assign it to one of the existing buckets, no matter what the input is or whether it was seen before. In the end, the new category will fall into one of the existing buckets, and the application will continue running, normally without stopping. But of course, we are aware that the new input will result in a prediction that's not as accurate, because the model hasn't encountered this airport in training. We should acknowledge that any new input will likely not yield the best prediction. But the advantage is that the prediction will be based on the existing data in the bucket, which is better than nothing. The model will use what it learned from the bucket and apply it to the new input. So it's not the best solution, nor the worst. Also, when we said we will treat missing or unknown features, in this case, the missing data that the model deals with will have almost zero impact or very small values. For most cases, the model will likely produce a very poor accuracy. However, in this case, we can take information from other features that are present in the same bucket at least. Also, when we said we will be using the missing or unknown feature from the one-hot encoding, in this case for unknown categories, the new missing data that the model deals with will have almost zero impact or very small values. For most cases, the model will likely produce a very poor accuracy. However, in the hashed feature case, we can take the information from other features that are present in the same bucket at least. Now for cardinality, I believe it's clear how the problem has been solved. Instead of having 347 airports, we now only have 10 buckets. And those 10 buckets, if each one represents a feature, could result in 10 features instead of 347. That means each bucket contains roughly 35 airports. The book also suggests that you might want to choose a bucket size that ensures each bucket contains around 5 items. So in this example, we might have 70 buckets. This way, you avoid placing too many airports in one bucket and assuming they are similar without knowing for sure whether they are or not. At the same time, you don't keep each airport as its own separate feature. This puts you in a situation where you're balancing between the pros and the cons. And if you have thousands of hospitals or doctors in your data, you might end up with hundreds of buckets. This helps you maintain a reasonable size of your model and its features. Finally, regarding cold start, it's similar to the auto-vocabulary problem. If you get a new input, it will still fall into one of the existing buckets that the model has already learned from. It won't give you the best results, but it will still give you a prediction based on the learned buckets. But the important thing is that over time, you should retrain your model periodically. At that point, your model will learn from the new data and improve with future updates. And at the same time, if you get a new input, it won't result in a completely poor prediction. Let's now take a look at the advantages and disadvantages of using this design pattern, when to use it and when not to. We will discuss all of this in the trade-offs section. The first issue is bucket collision. This happens when multiple categories end up in the same bucket, even though they might not be related. This is obviously a lossy process, as it loses some of the original information you had. Instead of the airport having specific characteristics in your data, the bucket now has different distributions of these characteristics. So the book suggests that if you already have the full vocabulary, you might not need to use the hashed feature. Or you might use it when the vocab is relatively small. For example, if you have 1000 categories and 1 million data points. The collision problem becomes more prominent when you say, I'm going to create 100k buckets for the 347 airports. You will find there is a 45% chance that some airports will fall into the same bucket. So the book suggests that do not use this pattern unless you are aware that some categories might collide with each other, even if they don't overlap directly. Another issue is skew. This shows up when we look at the model's accuracy, which might not be optimal for some airports, especially airports that fall into the same bucket, with another airport that has more data than the rest. As you can see in this example, ORD airport contains most of the data for the bucket. So when the model learns from this bucket, it's likely to learn more from ORD than from the other airports in the same bucket. This is similar to the imbalanced training problem we discussed in the first video. The book also adds a note about bucket collision. If you increase the number of buckets too much, things become sparse. But if you decrease them too much, you will have a lot of collisions. So the bucket size becomes like a hyperparameter. You need to tune it just like any other hyperparameter to find the optimal size. Another important point discussed in this book is the aggregate feature. The two problems we mentioned earlier are that categories might be skewed or there might be too many collisions within the buckets. So the book suggests adding an aggregate feature. This means creating a new feature for the model to learn that helps it differentiate between the categories in the same bucket. For example, if we add the probability that a given airport will have an on-time flights, this feature will help us distinguish between different airports within the same bucket. The model can now differentiate not only by the bucket, but also by the characteristics of the data within that bucket. For a given bucket with 3 airports, one has 30% on-time flights and the other 70%, and the last one has 99%. With these informations, the model can now differentiate between the different airports and not use the bucket combined features only. And actually, if you think about it, we might not need to use hashing or even bucketizing at all. It might be enough to track just the timing information of the airport without worrying about its name or type. So always keep the pattern in your mind and don't use it without thinking about it first. If you have an aggregate feature that helps after hashing and the model can learn from it, then use it. Or if the aggregate feature is useful on its own, you might not need hashing at all. Now let's consider the other side of the problem. After defining your bucket size and processing the data, you might find an empty bucket. In cases like this, it's better to apply regularization to the model so that it assigns almost zero weight to that bucket. This is to avoid the model responding to randomness during inference, especially since this feature has not been seen before and it has not been updated with any gradients. Finally, the last point the book mentions is the order of the operations. The farm fingerprint hashing function returns an int64. This number ranges from the negative huge number that ends with an 8 to the positive huge number that ends with a 7. And if you're not careful, the modulus operation is before the absolute value, because there is a rare chance it could cause a small error if the function returns a negative number, which is the negative large number that ends with a negative 8, as the absolute value of this number won't work inside int64. To avoid this, we apply the modulus first, then the absolute value. And that's all for today's design pattern, which is called hashed feature. And as a quick summary, we talked about 3 problems with categorical features: out of vocabulary, cardinality, and cold start. Then we explained how the hashed feature design pattern helps solve these problems. Then we explained how the hashed feature design pattern helps solve each of these problems. We ended with the trade-offs, discussing when to use and when not to use the hashed feature. And that concludes today's video. I hope you found it useful, and if anyone has any questions, feel free to post them in the comments. If anyone has any comments or feedback, please write them in the comments as well. I'll see you in the next video inshallah with another design pattern, so stay tuned. Take care and bye bye.